you know that for the ferrous metals, there are things that consist mainly Fe, right? Metal, iron, right? So as long as it's the iron family, then we call it ferrous metals. And roughly you see for the rough iron, these are we have the carbon content of how many? 0.2 to 0.5%, right? Cast iron, 2 to 4.5%, right? Okay. And then for the other one is talking about high yield steel is very low carbon, right? And then it is less than 0.15%. Okay? So usually for high yield steel, the carbon content is very, very small, right? Okay? Look at your step for the PowerPoint. Okay, just go through it. So the carbon content for various types of steels, you just get yourself familiar what are the carbon contents for various types. As just now we say that we start from where? Rough iron, cast iron, right? Actually here. Okay, carbon contents. Okay, I think here will give you some of the stuff. So you can see that the steel actually from this is iron, and then this is steel, alright? So the highest one is what? Big iron, right? Highest content. And then the smallest one is dry iron, and then the steel is somewhere around. It's quite low also, right? Around this range, right? It's second lowest, 0.25 to 1.5. It's not as high as all these big iron and cast iron, right? Okay. Actually, what is the purpose of iron, of the carbon inside? The carbon will do what kind of things for the steel? What is the main function of the carbon? I would say function, what kind of property they will give? What kind of property? Can anyone tell me what kind of property they will give if you have carbon content?
Higher hardness.
Just now we have go through one of the point there, right? Which page? Yes, we can have hardness as well as what? Huh? Higher contents of carbon, how does it link with how does it link with the brittleness? Down here, what value may contain carbon ranging from 0.2 to give it a bit more hardness and brittleness. So I can say that if you have I can say that the carbon will give the property of more hardness as well as more brittleness if there are carbon contents inside. So it's always linked with like high carbon will have high hardness, will have high brittleness. And then if you have brittleness low, that means your toughness is toughness and brittleness is always opposite, right?
Yeah.
So if you have a lot of carbon, that means it's very brittle, right?
Yeah.
So the toughness is low. Okay? So now it's just to tell you that roughly you must know what are the carbon contents in all those various iron family. And then carbon will give you hardness as well as brittleness. Okay? Is it okay? Okay, down here it says the effect of the carbon, right? Control the hardness and the stiffness of steel. Increase in the carbon will increase the strength, the brittleness. Right? Just now it said increase brittleness as well as hardness. Yeah. And down here they have additional things like just now hardness we mentioned already, and then stiffness we did mention, but usually stiffness linked with the elasticities, okay, and then also increase the strength, okay, but it will cut down the ductility, okay. Okay, so maybe to conclude, I think this one is a better one, easier to control. So the effect of the carbon will give more hardness, more stiffness, more strength, and more brittle. So these are the three, right? 1, 4. 1, 2, 3, 4. Right? So if you decrease it, then there will be the other way around, right? Sorry. This one it says that if you have high carbon, you will have high hardness, high stiffness, high strength, and high brittleness. But the negative effect is it will decrease the ductility. And then actually this one, resistance to shock, less resistant is the same thing as brittleness, because we just now say that if your carbon increase, your brittleness will be high. If your brittleness high means that it is less resistant to shock. Understand? Yeah, so to conclude all this, so just to tell you the effect of the carbon. Is it okay? Here they mentioned the high tensile steel is a low carbon steel, and then it is less than 0.15% carbon. So that is high tensile, high strength steel. So sometimes we call high tensile steel, sometimes we call it high strength steel. Their carbon is always less than 0.15. Is that okay? Okay, next one talk about alloyed steel, right? What is alloyed steel?
Stainless steel.
Alloyed steel is stainless steel belong to the family of alloyed steel. So basically, if you say alloyed steel, that means that the main one is the steel that combined with other metals or minerals. So which are the important one they combine to get alloyed steel? Steel combined with who?
Sulfur.
Nickel. So nickel is for what purpose? Why you want to put the nickels inside the steel? To increase the strength. Okay? And then what else? If you want to put, then the second important one is chromium, right? Why you want to add a chromium inside?
Resist the corrosion.
To
Resist
resist
corrosion.
the corrosion, right? Why you want to put down here? Hardness is for what? When you add what? Manganese, then will give you hardness. Okay, so for stainless steel, it belongs to the family of alloyed steel. Why you call alloyed? As long as metals mix them together, the end product we call it alloy. Okay? So now we call it alloyed steel is because the main thing is still the steel, but you add other things into it, and then you produce the final product, we call it alloyed steel. And then that's why I say that is the stainless steel for the case where you add the nickel for what? For strength. You add the manganese for what? Hardness. You add the chromium for what? For resistance to corrosion. Understand? So all these are important things about alloyed steel. Okay, we have mentioned about heat treatment for steel, right? This heat treatment is like how are you going to go through the heating process to the steel to give different kind of property. So different kind of property you wanted, you will use whatever kind of method. Okay? So if you talk about normalizing, means that you want to get the steel to what? To increase the uniformities. And then what do you do? What do you do? How do you do? How do you do normalizing? You must heat the steel at A1, A1.5 or higher, and then cool it in where? Cool it in air. So if you say cool it in air, definitely logically you will say that the cooling rate is slow. Not very slow or very slow? Very slow is furnace. You will cool it in furnace very slow. If you cool it in the air, still fast, but not the cup. I mean relatively it's become not very slow, but it's still slow. Understand? So you must remember you cool it in which media, then it's logically you will make sense how fast, how slow. Okay? Water, very fast, right?
Yeah.
Air,
Slow.
slow. Furnace,
Very
very
slow.
slow. Then and you don't need to remember by heart. So again, normalizing is to heat up to this temperature and then
Cool down.
cool it down in air, and that will lead to because I want the cooling to be slow, so that I leave it in the air. So this is finally I will get the property of the steel that has better uniformities. Okay, what do you mean by uniformities? The density will be more or less evenly distributed for the whole process of steel. Alright? I don't want to have some portion high density, some portion less density. So we talk about uniformities. Second one is what? If you want to have what kind of property, then you will use the annealing. You want to what? Toughen and cut down the bitterness. You don't need to remember two, right? I told you already. If you make it tougher, that means your bitterness will be low. So you just remember one, high toughness, that will lead to low bitterness. You don't need to remember two, because we say that toughness and bitterness are always opposite. Understand? So you just remember toughness high, okay. Then this one, understood, you will know that bitterness will be low. Understand? Okay, how you do it? Slightly lower than the temperature of the normalizing. Okay lah, may not be that critical lah. Some always remember 815 lah. And then how fast you want to cool it down?
Very slow.
Very slow. Why? Because you cool it in the furnace. Understand? Okay. What is quenching? What kind of end result you will see if you do a quenching?
Increase hardness and strength.
You can increase hardness, you can increase strength,
And reduce temperature.
but toughness, as what I say that, yeah, but anyway, there is no related one. You can increase hardness, increase strength, but you will cut down ductility, and then you will cut down toughness. Understand? So this one got extra thing to learn. Increase hardness, increase strength, but you will cut down ductility and cut down the toughness. So where do you put it? Put it in air, water, or ground, right? All these are liquid lah. Then that means that you want to cool it very fast, right? Just imagine all the liquid, put it inside, the cooling rate will be very, very fast to cool down, right? Okay, so that's quenching. Tempering, what is the purpose?
Reduce residual stress.
So tempering is the following up for quenching. Let's say after doing the quenching, you will find that the end product is bad in the sense that negative effect got less bitterness, got less toughness. Alright? So you want to make good to this, then you do a tempering. Okay? So after doing the tempering, you will be able to what?
Greater hardness.
Have better toughness, isn't it? Okay, so this is what it means. Okay, so how you do it? You take the quench steel. You must go through the quench first, then you go the tempering, right? So the temperature you keep it reheat to 150 to 650, and then cool it in the air. Okay, and then like that you'll be able to cut down the residue stress because before that there are some heat trapped inside, and then that will, why heat can trap inside? So now you want to cut down the heat that trapped inside, because if you do quenching, a lot of heat trapped inside, that will have thermal stress. Thermal stress will lead to crack and things like that. Why? Because quenching, you cool it down in the water or in the oil very fast. So when things cool down very fast, it will not be like things cool very slow, right? If things cool down very slow, the heat will start to, what I mean is, if the thing cool down very slow, the heat slowly will transfer, and then everything will be more stabilized. If you just straight away put inside the water, suddenly the heat just lost, and then internal will have some of the leftover heat. So that is not so good, you know what I mean? The same thing as what, if you put, get something from the freezer and then you want to do a deep fry in the so-called hot oil. Then once you put inside very fast, the surface will be cool, but inside is not well cooled. Why? Because the thing is already frozen in a low temperature. Then now suddenly you make it into very deep oil. Of course, outside layer will get cooked very fast, but inside cannot. So because of the heat transfer, when you go inside, it become very suddenly you encounter a very hot oil. So the heat just only can take over the so-called surface, and then inside still temperature not so high, still low. So that's why when you eat inside is undercooked, right? Same thing as this one, the other way around. At first it's very hot, right? Then after that you want to cool it, right? So if you cool it down, let's say that just like something very hot, you put inside the freezer. If the thing very hot, right? You straight away put inside the freezer. That means that it will cool down very fast, right? But inside may not be so cool down so effectively. So these are the residue stress. So in order to handle this problem, you will do a tapering to settle all the leftover stress, leftover heat. And then finally you get what kind of result? You will have a better hardness. And then also can have better strength. And then can have better wear resistance. And then can have better toughness. But here it says that if you want to have a better toughness, then your heat will be higher in a certain range here. But don't need to understand, don't need to memorize something like that. Just know that the heating temperature somewhere around 150 to 65, and then the end product is you expect to have higher hardness, strength, wear resistance, and toughness. That's it. Understand? Okay? So far, okay. Can So let's say we go to, if you don't really understand what are the terminology, right? That's why I said the first page will give you all this thing, right? So what we mean by ductility? Ductility is the property of undergo large plastic deformation before actual failures. The properties of ductility enable a metal to be drawn out into thin wires, beat it into thin foil, and undergo large deformation. So ductility is more like the flexibility there. Before the thing breaks, the metal will behave like that, so that it won't be straight. Suddenly there's a break, So it's because of the things about the ductility. It will stretch, it will go into very, very thin layer before it breaks. If the materials don't have ductility, because metal usually have ductilities, But for concrete, normally don't have much ductility, right? So that's why when you break, immediately you will just break. You don't have that kind of symptoms to show you the thing is already stretched, about to break already, the ductility there. So ductility is good in that sense. Okay or not? Okay? So it's just like like human like that, you must have some ductility there. If you are under stress, you'll be able to be resilient and then you'll be able to absorb. Not immediately you just fail and then die already. Must have ductility there. Huh? We talk about hot forming and cold forming, right? Remember? Hot forming and cold forming, right? Okay, so what is hot forming? Hot forming break up the coarse grain and increase the density by closing the tiny air holes and force the grain closer together, right? For cold working, it will elongate the grain in the direction of the steel elongation. It will increase the strength and hardness, but it will cut down ductility. So these are the difference between hot and cold forming, where you want to form the steel into whatever shape you want to have. So basically, this is to tell you scientifically what do you mean by hot, what do you mean by cold. So this one is to break the grain and then after that close down the gap between the grain, right, among the grain. And then cold is not breaking. Cold is just to extend the grain and then the end result is increased strength and hardness. So this is the definition of what do you mean by hot working, what do you mean by cold working. It's the same as forming, form. Okay. Then we say good and hot and cold. What is the difference? Forming advantages. In your tutorial you have, if you use a hot forming and then if you use a cold forming, what is the difference between them? Just now the one is to explain scientifically how the grain will get broke into pieces, that is hot. If you get extended, that is cold. But finally, what is the end result? Finally, what's the end result? Here. It's the same paragraph, right? Okay. Cold forming results in more accurate finished product because there is no cooling shrinkage to be estimated. The surface are smoother because oxidization still does not form and it does during the hot. So overworking, whether hot or cold, will cause bitter. This one okay lah, never mind. This one you say that you don't care whether it's hot or cold forming. If you overwork it, then it will become very brittle. Okay, maybe you don't need to bother this, but it's just that the tutorial that we have mentioned things like that, right? So can conclude or not? Hot and cold working, what are the difference? So for cold working, what is the advantage?
No shrinkage.
I think your tutorial says that cold working is better than hot working, right? Okay, so what are the advantages for cold working? No oxidization means what? No oxidization is one. The other one, no shrinkage, is another one. So no oxidization means good thing because because surface will become
Smoother.
right? The other one, no shrinkage, right?
More accurate.
Because no shrinkage, so the end product will be more accurate dimension. All linked together, understand? Can ah? Can ah? Can ah? Okay, all this is for test only, but comes to exam, I will find another time to do a revision. So don't worry about the exam first. So for the test, for the test, I think you need to know this only. For the, here, corrosion prevention, right? We call it prevention or call it limiting corrosion. Okay. So, what are the methods that you use to prevent steel from corrosion? So, these are the 4 methods. First one is use alloy steel, right? So that means that you use the stainless steel. One method. Second method, paint the steel with metal coating, right? And this metal coating that you paint on the steel must have the property of anodic. What do you mean by anodic? They must be able to give away the electrons, right? So that when it comes to corrosion, the outer piece, this so-called the coating, right, will get corroded instead of the steel get corroded. So in this case, sometimes when you go to the website, they call it sacrified metal coating. Why you call it sacrified is because the material you use for coating, it will get corroded first, and then indirectly you are protecting the steel underneath. Or you say that you are protecting the under the substrates of that. Substrate means that the thing is underneath this coating. Okay, the substrate of this coating means that the thing is underneath this coating, and that is referring to steel. So okay, if you don't really understand that, then you learn by heart anodic metal coating. What is the example of that metal you use to prevent the coating, to prevent the corrosion? You can use zinc or chromium or aluminium, right? But you cannot use what? You cannot use copper, right? Because copper will behave differently.
Yeah.
If you put copper, that means what? The copper will not get corroded, but the steel will get corroded. So cannot. So that depends on the chemical reactions. Depends on the chemical properties of that metal piece. So conventionally you use it. Okay. So if you want to study more, you can go to the Google and see how corrosion takes place, which is quite interesting because it involves in all the movements of electrons. And then we say that the metal coating must be active than steel. Active means what? They give away the electron faster and easier compared with the steel. Understand? So there's another way we call it sacrified metal coating, right? Because sacrified, he himself can protect the steel below. Understand? So as a human, as a daily life, are you going to do the anodic coating for your loved ones? Yes. Hope so. Okay, next one, chemical treatment. Okay, basically chemical treatment is just because of the two materials, you put them together, then you have a chemical reaction, and then they will have layers of things that produce on the surface of the steel, and then that directly do the protection for the steel. So you can see more description here, chemical treatment, right? Steel objects can be produced by dipping them in the bath of the so-called phosphoric acid, a stable film of steel. This is a new product, right? Because of the phosphoric acid have chemical reaction with steel, right? Then they will produce a layer of iron, phosphoric, and this will protect the steel against corrosion. So it's basically acid chemical reaction with steel and produce the so-called iron phosphate, and then that will become protecting the steel. Okay. So the stabilities of the phosphate surface layers and hence the effectiveness of protecting layers is increased by dissolving zinc or so-called manganese in the bath of hot. So this one is the additional things you can add in. You can add in zinc and add in manganese. Actually, it's quite related to what? Yeah. Okay, maybe if you find too much thing to remember, maybe the last sentence you don't need. You just say that you just dip the steel inside this acid, and then you produce another chemical layers, and then that will indirectly protecting the steel. Okay. Here is more like for what? Effectiveness. Effectiveness means what? Even stronger, better protection. Effectiveness. Understand? More effectively if you add the zinc inside. Okay? And then of course the last one is protective bending. Okay? So these are the 4 methods you will use for steel corrosion. Is it okay? Okay, that is for steel. Any questions about this? Any questions about this? Okay, any questions about this topic? A lot.
5 topic lah this one.
Huh?
This test got 5 topic lah.
This test, yeah, until the end of the topic,
Until
then it's
the
really
main
topic.
topic.
Yeah.
Then how about the exam ah?
Exam I will tell tell you later on
It's
after
seven
the
topic.
after the test 2, you still have lesson, right?
Yeah.
Then I will give you the revision for exam.
That one is how many topic? 1 to 7.
That one all.
That one is
Yeah.
Oh,
Yeah.
yes.
Exam of course all.
Why is seven?
That means that on that day the test is the week after the national day, right? So it will be 9 plus 7, that's 16, right? So 16 will be your test. Then after that 16 plus 7, that is 23rd, right?
Yeah.
So before 23rd, there's one lessons. Okay lah, 23rd, then I'll give you a revision for the exam. When is your exam date? Your exam date is next, another week later, that is I think on the 27th of August, right? Is it 27? 27 or 26? Monday, start from Monday. Monday is 26 or 27?
26.
26 is Monday. And then Monday is your exam.
So 16 and 26. Yeah, 16 is on the Friday.
Yeah, that will be your test. Then,
26 is exam.
yeah, 26 is exam. But on the 23rd, you must come back, right?
Yeah.
And then before 23rd, there's one Monday, right?
Yeah.
That is
19.
19.
19.
Yeah.
You still got 1 week to do the revision, right? Or is that right? That will be okay, right?
Think so.
Why not okay? Or maybe I will do a revision for 19, no? At least not drag until 23rd, right? Do a revision on 19, still okay. Is it okay? Can I? Anyway, have you finished your assignment already? Then? Okay, so far okay before I proceed to topic 4, bituminous material. Okay, what are the common defects you can find in bituminous pavement, also called the surfacing? This one is on page 12, right? So what are the common defects you can
Crack.
find? Huh?
Surface crack.
You can find cracks. And then
Slurry.
blistering, and then deformation, and then embankment. These are the four, right? Cracks is very common, so why you can have crack? Because of the stress, then you will have crack, right? So stress comes from where? So it's a lot of things already. Stress can come from loading, right? Stress can come from loading, right? Can come from thermal expansion, right? Okay, let's see from the loading itself. How does the crack come in? Because of the loading, it will lead to the road different settlement, right? So some portion set more, some portion set less. So when the partial settlement, right, it will lead to stress. If there's a stress, then you will be cracked. And this settlement also link with your compaction, right? Just like the road like that, right? If here you compact a lot, here you compact less. So when vehicle just go by, the load will get acting on the road, right? So this portion that you compact a lot one will settle less. This one you compact a little bit one will settle more. So here settle more, here settle less. Then you will have stress. Stress, you will start to have crack. Understand? Different settlement, Of course, here they have more even detailed things. Okay, blistering means what? There is a what? Moisture trapped inside, right? Okay, so this moisture come from where? Come from underneath, right? So if you have better waterproofing, so that the water won't easily get trapped inside the bituminous material, and then you can solve part of this so-called blistering problem. Understand? Deformation is basically, again, we talk about loading that cause the road to get deflected, change shape, and all these things, and that lead to stress. That then you will have even more problems. Then crack will become bigger and bigger, and then that will be a major problem. Then sometimes you can find a pothole, right? The whole road got like a pot like that, and then when it comes to raining, a lot of water inside. So water inside worse because you will penetrate through, and then after that the vehicle will pass by, and then you make the crack even bigger. Then the pothole become bigger and bigger. So that's why you can see the road. If there's a small patches, the small hole there, you don't do it right, it will become bigger and bigger, and finally there is a problem. That is because of the road deformation. You never make good to eat fast, and then that leads to this problem. Understand? Okay. Next one is talking about embankment, right? But this embankment is more for this one. We are talking about it should be the best way is what? A, B, C, which one is the best way? A is the best way, right? B, not good. Why not good? The bitumen is too thin layer, right? And then the stone chipping you want to spread on it, you cannot get embedded properly, right? See? Bitumen is too much, and then the stone will get embedded inside, and then you cannot create a rough profile, and then the safety got problem, right? So this one thin, this one big. So common sense will tell you cut down the size, thicken this one. Right? This one's small, this one thick. So what is the remedy? Make a bigger size and then cut down the thickness. Logically, these are the things. Is it okay? So you want to do it with this. So embedment is talking about what embedment are? The chippings that embedded in the bituminous layer. All this is talking about what? Surface dressing. Okay? Why you want to have surface dressing? Surface dressing. To dress the road with bitumen and stone chipping, right? Yeah, so we call that surface dressing. Okay? And then if they are not embedded properly, then you have all this problem. So this is embedment. Understand? Is it okay? So the common effects for the bituminous pavement, crack, blistering, deformation, and the embedment. Is it okay? What is the property of this bitumen? What is the property of this bitumen? What do you mean by penetration grade? Penetration grade is to measure what? Measure what? The penetration, right? The penetration of the needle to penetrate through the bitumen sample, right? If the penetration grade high means what? I don't remember. Where is the picture to talk about the penetration? Remember I said if it is what 35 pen means what? Remember? Which page is that? I think it's in front. Is it in front? Anyone can find the penetration? Where? Here. Page 5, right? Page 5, penetration rate, right? So you said if the bitumen is having a grade of 200 pen, means what? Means that when you conduct the penetration test, the needle will penetrate 20 mm. Right? So if you choose a grade of the penetration grade of bitumen, if you say 30, so means what? So if the grade of the bitumen you choose is having a grade penetration grade of 30, we call it 30 pen. So 30 pen means what? Means that the needle will penetrate 3 mm. So all these things will relate to what? Penetrate more, penetrate less. That is related to what?
Hardness.
Hardness. Huh? Understand? Yeah. And the other one is talking about softening point, right? What is softening point? Softening point in the experiment, we talk about you heat up the sample inside the water container, right? Which is hot. Then you increase the temperature right here. Remember? All these are all water, and then the bitumen is here. Alright? So if the temperature increase for the water, the sample here will become soft. When this one becomes soft, this steel ball will sink down, right? Easily, right? If not so hot, then you won't sink down so easily. So the softening point is referring to the temperature, alright? So if the sample of the bitumen having a high softening point, right? Compared with here, 53 degrees C. High softening point means what? Means that this bitumen is very hard. Because we're talking about hardness, right? If the softening temperature is very high, that means that I must raise a very high temperature so that the bitumen will turn soft. So indirectly, this kind of bitumen must be very hard. If this is very hard, you can see the pen is 35 pen. Because when you do the penetration test, the needle can only poke through 3.5 mm. Understand? So from here you can see the higher the lower the pen, the lower the pen, the higher the softening point. So softening point is talking about temperature. Okay, same thing go to here. If you choose the bitumen grade that is the grade that is 300 pen. 300 pen means what? It will penetrate 30 mm. So that means that the bitumen will be very soft. That's why it can penetrate. If the material is very soft, that means that the softening is very low because I just raised 34 degrees C, turned soft already. The nature of that bitumen is very soft and very easy to melt. Understand? And then it linked with what? It linked with viscosity, right? Remember what is viscosity? The thickness, right? The fluidity. If the so let's say we talk about softening point, right? This one softening point very high means that the bitumen is more sticky or less sticky. Okay, this one softening point very soft, right? Very low, right? So the bitumen is more sticky or less sticky? It's less sticky, right? So if it is less sticky, we say that the viscosity is low. Alright? Same thing go to here. If the softening point is very high, means what? Means that the bitumen is sticky. If it is sticky, means what? viscosity is high. Understand? The kind of relationship, okay now? So always talk about viscosity when you talk about softening point. Okay, so again, here, softening point is high, so the viscosity is high, correct. This one, viscosity is low. So when you talk about softening point, we always link to viscosity. Is it okay? Can you understand the logic or not? Can not? Huh? Explain one more time. What? Do you have some food that is like bitumen? Any food? Sticky one?
Porridge.
Huh?
Porridge.
Porridge? No lah, porridge is still very like mochi. Have you eaten mochi? The Japanese food, mochi, the sticky one. Yeah, sticky one, right? Just compare lah, two mochi, right? The sticky one. One is very sticky, very hard a bit. The other one is less sticky, right? The base is very soft, right? Okay. So if you heat them up, which one will turn soft very fast? The less sticky one, right? Because it's already very soft already. So you heat them up, they can turn soft very fast, right? This one a bit hard one, it will take more temperature, right? Okay, so this one, less sticky one, soft one, the softening point is low, and then the viscosity is low because it's less sticky. This one, hard one, right? Viscosity is high. That means that you want to turn them soft, it's more difficult. So you must have higher temperature. Cannot. 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 Talk about it, then you can understand. Okay? Okay? Okay, the other thing is, this kind of softening point, all these things, right? That means that why you're interested in softening point is because hot temperature, the bitumen will turn soft, right? Low temperature, the bitumen will turn hard. And then, one thing is, if the bitumen subject to low temperature, it's not just turn hard only. Another important thing is what? It become very easy to break by shock load. That means what? Become very brittle. So this is the important thing about the softening point. So that means that when it comes to winter time, the bitumen will tend to become brittle. Yeah. So if you want to study detail about this kind of thing, then all this the brittleness of this bitumen is very important. You cannot use the materials that when it comes to winter time become very easy to break. And that is talking about the property of the brittleness. Is it okay? I think here the notes here never talk about brittleness, right? They talk about brittleness. Usually if I talk things about brittleness. So that means one more thing you have to take care is when it comes to bituminous material, right, when temperature go very, very low, that means like winter time, the property can change. It cannot be that soft already, right, because it's low temperature will cause the thing to become brittle. So these are the things that you need to know. Okay? But when it comes to hot weather, you become what? You can become so soft, and then you got problem already. Because if it's so soft, then how? If the vehicles give a load, then the road will get sink down because of the bitumen is very, very soft. Okay, So any questions for this topic before I proceed? Okay? No? Then we proceed to the next question. Next topic is what? Brickwork. Brickwork. Okay, next one is talking about, okay, let's say that this is a brick, right? What type of brick is this? Huh? How many holes here? So what kind of brick is this? Hollow usually not many holes. Like this one you can see there's an empty space like that, right? But this is not hollow because this face is hollow, but bottom there, the other big face is not hollow, right? So if it's hollow, got to be punched through, right? Yeah, so it's not considered as, this one is can be considered as a what? Cellular, which is flop, that means create a kind of space, but it's not punching through to the other big. So this is flop or cellular, but this one is what? Perforated, right? So what is perforated? You punch a lot of small hole. That means that this is the top big face, right? Bottom big face also the same thing. So the hole punch through one. So the whole thing we call it perforated brick. Understand? Can which is quite commonly available in the construction. I mean, this is a brick that, as you can see, a lot of hole punching through from one big face to the other big face. Remember, we said this is big face, right? This face is big, right? Bottom one also big face, right? The side one you call what? Stretcher face. Then the head and the tail one you call what? Tailor face, right? So perforated brick is many holes punched through. Then okay, down here it says for perforation, there is perforated brick or frog brick. Frog is this one, right? Yeah. So indented there's no punching through, but for perforated one is punching through. Why you want to have the, okay, let's say you just concentrate on the perforation. Why you want to have punching through? Because why you want to create so many holes for what? Create so many holes, we call it perforated, right? Why you want to have so many holes? For what purpose? Here, tell you already. To assist in forming a stronger bond between bricks and the remainder of the structure, right? So that when you want to put in the cement mortar into the holes, then you will have a better bonding between the brick and the other face of the structure. Is it okay? Okay. Then to cut down the effective thickness of the brick and hence cut down the firing time. So the end result is cut down firing time, right? Why cut down firing time? Because the effective thickness get reduced. That time I explained before already. Why? Because you said you calculate the whole volumes of the brick. If it's solid, you take this times height. That's a solid volume. Let's say that now you cut all these holes already, right? So if you calculate the volumes, right, it will be lesser volume, right? Because all these are occupied by air only, right? Lesser volume. So to have a lesser volume with the same dimension of this, then your thickness got to be cut, right? To have a lesser volume, right? So that's why you say that the effective thickness is reduced. Why it's reduced? It's because of the volume get replaced by the air. Alright? Understand what I mean? Okay, like for example, what is the volume of this brick? 1 102 times 215 times 65. Right? This is the volume. Okay? For a solid brick, or a solid brick. But let's say now I want to have perforated, right? Means what? I will punch hole, right? So once I punch hole all these things, the volume will cut down already, right? Okay? So inside all occupied by air, so volume will cut down. So how to find this volume? This one, no change. This one, no change. And then this one definitely will be smaller one, so that you will have smaller volume, right? So the end result is smaller height. That is so-called reduce in the effective thickness. Understand? Understand what I mean? Okay. So if like that, then the brick will be easier to get fire. Yeah? Get fire means you turn the clay to become a solid brick, right? Using the heat. Okay? And then you cut down the material cost. Okay? So these are all the good things about the perforated. Okay? And then there's a control for perforated, right? Perforated brick generally contain less than 25% of the voids. Right? Okay, so this is a guideline for perforated brick, less than 25. Okay? Is it okay? More than 25, what happens? If you compare with the solid brick, if the hole you cut many, right? Let's say more than 25, then what happens? Will the strength affected? Yes, the strength will. You compare with the solid one. Solid one is got no hole, right? If you want to use a perforated one, yes, but not more than 25% of voids. If you more than, imagine many holes and then all are air, then what happens? Then the strength will be affected. Understand? That kind of logic behind. Is it okay? So the guideline is about 25% of the voids. Next one I'm talking about is rendering. What is rendering? That involved with mortar, right? Okay. So what is mortar? Cement, water, and sand. That is mortar. Okay. So for rendering, right? Remember we talked about rendering means that, okay, let's say that this is a piece of wall, but it's not concrete wall, it's a brick wall, right? Are you going just to leave it like that? Or you want to do one more layers of mortar to apply on it? We call it rendering. Some sort of like plastering like that. Okay? Usually rendering is more like for external because you will have sun and water, things like that. So we call it rendering. So to introduce layers of mortar on the surface of the brick wall, we call it rendering. Understand? Okay. So when you do this rendering, what is the main purpose? As what it says here, to prevent and to provide an aesthetically view, right? So that it's easy to maintain also because the surface is very smooth already, right? If you don't put a layers of rendering, it will be just a brick surface, which is very rough surface, right? So this is what it means. And then to resist rain and dam penetration, that means that you have one layer of coating on the brick wall. When it comes to raining day or all these things, that water want to penetrate, go into the brick wall, become more difficult. Just like you wear raincoat. The water when it come to your body become more difficult because the raincoat can protect you from water getting into the body, right? So it's the same situation. So these are all the function of rendering. Okay. So when you do rendering, what material you use? When you use rendering, what material you use? Just now we mentioned already. You use the mortar. What is mortar? Cement, water, and sand. Okay. So when you do the rendering, it's not so easy. The sand you use is important. Okay. Now here as what it says. The ideal thickness for there are two codes you need to apply. The correct techniques for rendering involving the application of at least two codes. That means first code, then after that you have to apply another code. So one code is not enough. Okay? The first code is designed to level the background and even out its suctions or water absorption. Water absorption is the water absorption of the brick that absorbs the water, which may vary considerably from place to place, being lower in the sense, this one you don't need because this is talking about lintel. What is lintel? Lintel is the top surface of the open like this one is the window, right? On top that one we call it lintel. These are all the window, right? On top of the window, that structure we call it lintel. Understand? Okay, but I think you don't need to go into that detail. It's just to know that because of water absorption, okay, where where am I just now? Where is just on which page? 17?
Yeah, 8 below 17.
Yeah?
No, so
This is 17
no, one's other the page, the PDF page, 17. Next one.
178.
Yeah, 178.
Yeah.
Next page. Yeah, this one.
Okay, so just now they give you reasons that you must have two layers. Alright, then the very first layer is for what purpose? First code. To level the background and even out its suctions or water absorption, which may be considered various from place to place. Okay? So all this you don't need to go into so detail. It's just to say that first code is designed to level the background and then even out its suctions or water absorption. Because from place to place there are different water absorption. So if you put the first layer of coating, at least you can even out the situation like that. Okay, this water absorption is what? Is the brick absorb the water, right? Water absorptions. Okay. Water absorption is critical in the sense that if you have too much water inside the so-called any of the material, it will lead to shrinkage, then later on it will lead to crack. So anything that lead with water, then you will tend to have shrinkage, then you have tend to crack. So if you have first layers of mortar, then you can cut down this problem. So the absorption of water will be lesser, then the crack will be eliminated or minimized. Okay, so racking of the so-called mortar joints like a good adhesion, right? That means that the mortar must stick well to the brick, right? So the ideal thickness is about 15 mm. So far, okay? Can, huh? So that means that you want to put a layers of this first coat, right? The thickness of the mortar supposed to be how many?
Yeah.
15 mm. Okay, the ideal one. Okay. I think this one only. Then later on, the final coat, the second coat, should be applied after the first coat has cured and dried. So usually it's about 1 week later. So some crack inevitably will occur in the final coat, but is obstruct in the coarse text finishes. The smooth render surfaces, a very fine crack network results will be in a very final is only a few. Smooth render are normally fully regulate with the paint which is correct. Okay, here the problem is talking about cracks and adhesion. Where's adhesion? Adhesion. Okay, so cracks and adhesion. So if you use the sand which is very coarse, the sand have bigger particle, then you will have adhesion problem. Cannot stick well. If you use the sand that is very, very fine, it tends to absorb more water, and then the cracks will happen easily. So mainly, I just want you to know things like that. Although here they never say anything much about size of the fine aggregate, right? The fine aggregate is the sand, right? Okay, to cut the thing simple, okay, again, if this is a brick wall, you don't leave it like that, right? You want to have rendering, right? That means you want to make the surface to be smooth by applying layers of mortar. So the first reason is you make it beautiful, and then second reason is later on when the water splash on the surface of the wall, it won't get so easily to get the water to penetrate inside. So we need to have this rendering. So when you do the rendering, you will apply two coats. First coat is the initial coat, that is undercoat, right? And then the second coat you put in is what? Finishing coat, right? So two layers. It's just like you do the painting. Okay? So the first coat, undercoat, for what purpose? For what purpose? Just now I tell you already. The undercoat is for what purpose? Which page just now we said? At least two coats, right? Then the first coat is the undercoat, right? It's designed to level the background and even out its suctions or water suctions. which may vary from place to place. So stop there. So you must know the function of the first code. That is the undercode. Okay? Full stop. Okay, the other thing I just want to mention is, the rest you don't care, right? The other thing I want to mention is, the mortar you will use water, cement and sand, right? So sand becomes very important for this rendering, right? Okay. The main general guideline, if the sand particle is big, if the sand particle is small, what will be the consequence? Okay, the answer is, if the sand particle is big, right? Cos means big. If the sand particle is big, what happened?
Less adhesion.
What happened? You will have adhesion problems. Means when you apply the coating, very difficult to stick. That is the first problem if the sand particle is big. Okay? If the sand particle is small, very small, also got problem. What is the problem? It will cause crack very easily. Because small sand particles, you need to more water to get mix it as a mortar. So you tend to have more water. More water will lead to water loss. Water loss will lead to shrinkage. Shrinkage will lead to crack. So I just want you to know the two general disadvantage, that is when the sand particle you use is too big. When you say big means coarse, C-O-A-R-S-E, right? If the sand particle you use it is too coarse, it will lead to adhesion problem, cannot stick properly on the brick. And if the sand particle is too small, what happens? It will cause crack. That's it. That only. The rest I think don't care. Just talk about the undercoat. The first coat, what is the function you are going to use, why you want to have undercoat, and then the other one is, if the sand particle big, what is the problem? Is the sand particle small, what is the problem? That's it. So far, is it okay? Can? Can? So that is the end for this topic. Before I proceed to the next one, is it okay? Any further question you want to ask? Is it similarity to painting? First coat, undercoat, prime coat. For what purpose? Same. Same in what sense? Can you elaborate?
Protection, make the surface nicer.
To even out the surface,
Not
the irregularities of the surface.
Color two coat will be nicer than one coat.
That is
Because it's
talking about the appearance. Two coat you will look more solid, more texture.
First coat usually will absorb inside the concrete already. Then you need second coat to make the color more even. Yeah.
Okay. Okay, any questions before I proceed to the next topic? So this one, what did I say for this topic? What did I say just now? Brickwork. What is the thing I mentioned just now?
Perforation.
Rendering.
So rendering, what are the things you need to know? Okay, you need to introduce two coat, right?
Yeah.
First coat is the undercoat, right?
Yeah.
For what purpose? To even out the surface, right? That is on which page again? Sorry.
178 PDF page. 178. 3 more page. Yeah, last one. I think over already over. Or below. Some more below. Last one. Yeah, rendering below. The last paragraph.
Over already.
没有在这边，就追yeah, the correct technique for rendering this.
The first code lah, that is the undercode, right? It's designed to level the background, right? What is the background? The background of the brick, right? The background of the brick. And even out its suctions or water suction. So this water suction, it can be just it can be the brick suction as well as the water suction. Okay, so it can even out its suctions or water absorptions. Okay, and then that's it. Then I say that the thickness is about, the best is about 15 mm, right? Undercoat, right? And then what else? Talking about the sand you use, right? If the sand you use is too thick, then what's the problem? Sorry, if the sand you use, the particle is too big, right? Then you have tension problem, adhesion problem, whether it can stick to the brick properly or not. Adhesion problem. If the sand you use particle too small, then you have what problem? Then you have crack problem. Why? Because if the sand you use very small particle, right? When you mix the mortar, you tend to have more water. More water leads to loss of water later, right? And then once there's a loss of water, strain. When you have strain, you have stress. You have stress first, then you crack. Understand? Yeah. So you must have the concept that things can get cracked. It's always stress. Then you have to ask yourself, stress comes from where? Understand? Yeah. Stress comes from where is very common. Loading, you have stress, right? Besides loading, you still have other things like loss of water that lead to shrinkage. So shrinkage is another reason, right, why you have cracks. And then the last one is talking about thermal, right? Sometimes temperature increase, you expand, right? Downstream. So there's a movement, right? Expand, shrink, expansion because of temperature. That will cause stress. So it will cause crack. Okay? So basically stress can come from three things lah. Loading, loss of okay lah, talk about shrinkage, shrinkage, and then the last one, the thermal expansion, right? Understand? Okay, next topic is what? Polymer, right? That's talking about plastic, right? What about plastic? Let me finish and then you go early lah. Left two more topic only, right? You're supposed to finish it. You mean what? You want to go break then come back later or what? Huh? Today is supposed to finish at 1:30, right? Let me finish and then you go back early lah. Okay, so for plastic, we're going to finish with not many. Okay, for plastic, you will know what is the application for plastic. The application for plastic, I will be more interested in the jaw application. So jaw application, what kind of application you have? Which page? Jaw grip, jaw composite, where? Which page? So that is an application for most of your construction industry. Which page?
193.
Okay, this one, jaw synthetic means what? Jaw means ground, right? Synthetic means man-made plastic. Okay, so man-made plastics that you apply in the earth. What are the applications you have? Jaw textile, jaw membranes, jaw linear elements. It can be a bar, but it's a bit of plastic instead of steel bar. And then you can have jaw grips and then jaw composites. So these are the application, the material used in the jaw, in the soil environment, and they are the so-called the thermoplastic polymers. Okay, so they are the so-called the jaw synthetics. So these are the example of it. So you must know these are the 5 categories that you apply for the jaw synthetics. Understand? So far okay? And then you must know the good and bad. There's one about the characteristics of plastic, right? Cannot get scratched very easily and all these things. This one, right? This is what under this one 6.6, and then this page. All this page is talking about what? Polymer, there's plastic, right? Fiber reinforced plastic means what? Not 100% this is 100%. Polymer is a general term about plastic, right? This one is inside the plastic you put fiber, so that's why you call it fiber reinforced plastic. Okay? Offer many advantages. So why they are good? Because high light transmission, all these things, okay? Resistant to water, that means waterproofing, right? Never get corroded because they are not metal, right? And all these are good things. How about the bad one? These are the bad one. Okay, scratches it's not good, and all this. The scratches resistance is not good. That means very easily you get scratched. So advantages and disadvantages. Alright? Okay? And that's it for your plastic before I proceed further. Is that okay?
The disadvantage also.
Wait. We cut it even smaller scope. Okay, you don't need to study the advantage, just study the disadvantage. Okay?
Disadvantage.
But actually it's quite related. So you just need to know the advantages and disadvantages, but don't need to learn by heart. Don't need to learn by heart. because this round I have set 5 questions on multiple choice, so easier for you to score. So this will be under multiple choice. Just read through and then 5 questions only. Okay? So this is part of one of the questions. Advantages, disadvantages of testing. No need to look by heart, you just scan through, then you will know. Actually, the answer is also very obvious. Okay? And this one is also, you don't need to describe, you just need to name all these words. Okay, understand? As what I say, for the question, if you see describe, explain, you have to write more. If I say states, name, or states, then you just put all these, no need to describe. Understand? Okay, so for the plastic, that's it. Before we go to the last topic, is it? Green. And this one paint no. So the green one, the green one, how? Okay, green one, you must know what is lean construction. You know what is lean construction, right? In your PowerPoint, there is a definition for lean construction, right? Okay, so you must know what is lean construction. You must explain what you mean by lean construction. And that's it. I don't ask much already. I don't ask much already. So just the last topic is talking about lean construction. So what is lean construction? Inside your got. Can you go to that? What is lean construction? And that's it already. Yeah. What is lean construction? It's sustainable.
Page 8.
Huh?
Page 8.
Page 8.
Yeah, this one.
Okay. So, lean construction should cover the following will cover the following key performance indicator. It means that if you have fulfilled this one, and so on, A, B, C, D, E, F, then it's considered as lean construction. Understand? So you must fulfill client satisfaction. You must fulfill the construction cost and time. Basically, it's management, project management, and then you must fulfill the minimum defects rectification. You must fulfill the profitabilities. You must fulfill the productivities, and then you must fulfill the safety. So you must include all these things in your project. So that is considered as the lean construction. Is it okay? Yeah. So big one, A, B, C, D, E, F. How many points? 6. 6 points there. So that is considered as a lean construction. Okay, actually quite common sense kind of thing. Is it okay? When you run project, of course you have to take care of the cost and time, right? Have you learned construction? Oh no, I don't think you all learned the project management yet, right? You all have not learned project management yet, right? So project management normally is talking about quality, cost, and time. These are the 3. Right? Take care of the quality, take care of the times, to complete on time, and then the costing. So it's always these three to mingle around. Okay, and then the rest as what we have explained in the lecture before. So these are the points that you have to take care. A, B, C, D, E, F. Okay, that's it for your green material. Any question you want to ask? For the latecomer, right, I say that the test 2 will be conducted on the 23rd August, right? That is 1 week after the National Day.
No,
That's,
it's
sorry, 16th. So it's National Day is on the 9th. Then another week that's on the 16th, right? So 16th will be the test 2. 2:30 2:30 at T31 or T310 is a combined. So that's it. Yeah. Then after that we, or maybe next maybe next Monday or whatever, then we talk about the exam. So today one is all talking about test 2 only. Okay? So far okay? Any question you want to ask pertaining to the revision just now? Huh? No problem. You have any test that crash or coming one? Other tests for other courses? Huh? Struktur mekanik.